Okay, Houston, I see what you're getting at. Hold on. Okay, Jack, tear that piece of tape down the middle lengthwise.
All right.
Hold on.
Well, the astronauts appear to have enough oxygen to keep them alive. One thing they have too much of is carbon dioxide. With each breath, the three men expel more of the poisonous gas into the lunar module cockpit, and the scrubbers intended to keep the atmosphere breathable are quickly becoming saturated.
I don't get it. What the frick, Caleb? It's so simple. I'm about to go bananas.
What's the point of this scrubber thing? The place looks pretty clean to me.
Well, it's not like an actual scrubber. The point of the scrubber is to remove carbon dioxide from the air.
Oh, so you mean this?
No.
What about this?
Well, no, Caleb.
What about this?
Caleb, no, wait. Yeah, wait, Caleb, where did you get this?
It's not important. Don't worry.
Oh, okay.
So how does this work?
Okay, well, if you're curious to know, I'll tell you.
Okay.
During the Apollo 13's mission to the moon, an explosion crippled the command module of the crew's spacecraft. The crew were then ordered to move to the lunar module, which the astronauts would have used to land on the lunar surface. Both modules have these, quote, lithium scrubbers, which remove carbon dioxide from the air in the cabin.
But how do they do that?
Well, it's quite simple, really. The crew has canisters of solid lithium hydroxide, denoted as LiOH, which are inserted into the scrubber. As cabin air is pumped through the filter, the lithium hydroxide reacts with the carbon dioxide to form lithium carbonate and water. The system proved to be quite the challenge for the astronauts aboard the Apollo 13, for too much carbon dioxide in the air caused multiple health problems, and if the problem hadn't been fixed soon, they would have died.
How so? Didn't both modules have filters?
You're right, Caleb, they did. However, the filter on the lunar module utilized canisters of lithium hydroxide that could only remove enough carbon dioxide to sustain life for 2 passengers, but there were 3, so the crew had to use canisters from the command module to keep themselves alive.
But the canisters from the command module were square, so they couldn't fit into the circular chambers of the lunar module's filter. Now I understand the issue.
Yes, good job, Caleb.
What I still don't get really is, how do they know how much lithium hydroxide they use?
Well, let's use our balanced equation to figure that out. Let's assume that the astronauts want to remove 50 grams of carbon dioxide from the air. How would we figure out how much lithium hydroxide they need to use, Caleb?
Well, first, you start with 50 grams of carbon dioxide. Then we convert grams of carbon dioxide to moles of carbon dioxide. 1 mole of carbon dioxide equals 44.01 grams of carbon dioxide. Next, we need to convert moles of carbon dioxide to moles of lithium hydroxide. 2 moles of lithium hydroxide equals 1 mole of carbon dioxide. Finally, we convert from moles of lithium hydroxide to grams of lithium hydroxide. 23.95 grams of lithium hydroxide equals 1 mole of lithium hydroxide. 54 grams of lithium hydroxide were used.
Okay, so how much water should have been produced from this reaction?
Start with 50 grams of carbon dioxide. You first need to convert from grams of carbon dioxide to moles of carbon dioxide. 1 mole of carbon dioxide equals 44.01 grams of carbon dioxide. Next, you convert from moles of carbon dioxide to moles of water, which is a ratio of 1 to 1. Then convert moles of water to grams of water. There are 18.02 grams of water and 1 mole of water. This gives us 21 grams of water.
Great, so we'll call this our theoretical yield. But let's say the astronauts were only able to remove 18 grams of water. What's their percent yield?
All you have to do is divide 18 grams of water by 21 grams of water and multiply that by 100, which gives you 85.71%.
Good job, Caleb. So let's use their actual yield to figure out how much carbon dioxide they really removed from the air, assuming that the lithium hydroxide is in excess.
You start with 18 grams of water. First, you convert from grams of water to moles of water. 1 mole of water equals 18.02 grams of water. Then, you convert from moles of water to moles of carbon dioxide. The ratio is 1 to 1. Now, convert from moles of carbon dioxide to grams of carbon dioxide. Since there are 44.01 grams of carbon dioxide in a mole of carbon dioxide, The actual amount of carbon dioxide converted was 44 grams. Get the box.
Isn't it cool how a little bit of chemistry can just save some astronauts' lives?
Yeah, math and chemistry is certainly an explosive combination.